Hello students, welcome back to Narayana Digital Classes. Today we will be solving the assignment number 30 on the topic solutions. Let's move on to the assignment. Here the first question, the degrees of dissociation alpha in terms of want-half factor is. So here we need to find the degrees of dissociation in terms of want-half factor. So first, what is degrees of dissociation? So degrees of dissociation can be defined as the fraction of molecule which can be dissociate into simpler molecular ions, right? For example, there is an electrolyte. So before dissociation, the number of particle initially 1, after dissociation there is no particle in the electrolytes, right? So after dissociation the unionized ions are 1 minus alpha, the ionized ions are n into alpha. The unionized ions are 1 minus alpha and ionized ions are 1 into alpha. So here alpha is degrees of dissociation. Alpha equal to degrees of dissociation. Right? Then now calculate the want-half factor. What is the want-half factor? I equal to before the total number of particles after dissociation, that is 1 minus alpha plus n alpha. The total number of particles which are present after dissociation, that is total number of particles 1 minus alpha plus n minus alpha by total number of particles before dissociation, that is 1. So then the want-half factor I equal to 1 plus n minus 1 alpha. 1 plus n minus 1 alpha. Now find the degrees of dissociation alpha, that is equal to alpha equal to I minus 1 by n minus 1. I minus 1 by n minus 1. So this is the degrees of dissociation in terms of want-half factor. So the correct option is second option. Clear? Let's move on to the next question. Here the question is, which salt shows maximum osmotic pressure in its 1 molar solution? So they have given 4 salts. Each salt concentration is 1 molar, right? We know that osmotic pressure directly proportional to want-half factor. Right? So all the concentrations are same. So that is pi equal to ICRT. The osmotic pressure pi equal to ICRT. So the which salt has the more number of ions, that has the highest osmotic pressure. Let's see how many particles are there. For example, AgNO3. So the AgNO3 can be dissociated into Ag2 plus NO3 2 minus. So the want-half factor for the AgNO3 I equal to 2. Next, Na2SO4. 2Na plus SO4 2 minus. The want-half factor for Na2SO4 is 3. Right? Next thing, NH4 thrice PO4, NH4 thrice PO4, NH4 thrice PO4. this can be dissociated into 3NH4 plus PO4 3 minus. So the want have factor for this molecule is 4. The want have factor of this molecule is 4. And the last molecule is MgCl2. MgCl2. That can be dissociated into Mg2 plus 2Cl minus. The want have factor for this molecule is 3. So among these 4 salts, which one has the highest want have factor that has the maximum osmotic pressure? If you see NH4P4 NH4P4 has the maximum want have factor, so it has the maximum osmotic pressure. So the correct option is third option. Clear? Let's move on to the next question. Here the question is, which solution will show maximum elevation in boiling point? This is also same. So elevation in boiling point, directly proportional to want have factor. I. So here also we have to, if you see the 4 options, all the salts concentration is same, that is 0.1 molar concentration. Now we need to find the want have factor for each and every salt. First one, KCl. KCl can be dissociated into K plus Cl minus. So it has want have factor I equal to 2. And next, BaCl2. So barium chloride can be dissociated into Ba2 plus 2Cl minus. So want have factor for this molecule is I equal to 3. Next molecule is FeCl3. It can be dissociated into Fe3 plus 3Cl minus. So want have factor for this one is 4. The last one is Fe2SO4 thrice. Fe2SO4 thrice. So this will dissociate into 2Fe3 plus 3SO4 2 minus. The want have factor for this molecule I equal to 5. We know that if the want have factor which was is maximum, that molecule has the highest elevation in boiling point, right? So here Fe2SO4 thrice has the maximum want have factor. So this salt contain maximum elevation in boiling point. So the correct option is 4th option. Clear? Let's move on to the next question. Here, the correct relationship between the boiling points of very dilute solutions of AlCl3 T1 and CaCl2 T2 having the same molar concentration. So we need to find the relation between the boiling points of AlCl3 and CaCl2. So this is also depend upon completely want have factor. So which molecule has highest want have factor, that molecule has the highest boiling point. Let's see what are all that. So AlCl3 can be dissociated into Al3 plus 3Cl minus. So the want have factor for this AlCl3 I equal to 4. And what is the next molecule? CaCl2. Right? So Ca2 plus 2Cl minus. The want have factor for this one is 3. Right? So which one has the highest want have factor? that has the maximum boiling point. So here AlCl3 boiling point is T1 and CaCl2 boiling point is T2. So the relation between T1 and T2 is T1 greater than T2. T1 greater than T2. So the correct option is second option. Clear? Let's move on to the next problem. Here the question is, if alpha is the degrees of dissociation of Na2SO4, the want-half factor I is used for calculating the molar mass, right? So here we need to find the want-half factor for a molecule which has degrees of dissociation is alpha. So before dissociation of Na2SO4, so the formula for the want-half factor is I equal to 1 plus n minus 1 into alpha. So here n equal to total number of ions. Total number of ions, right? So let's see how many number of ions are present. Na2SO4 can be dissociated into 2Na plus SO4 2 minus. So the total number of ions N equal to 3. Substitute N value in this formula, then I equal to 1 plus 3 minus 1 into alpha. So then I equal to want-half factor I equal to 1 plus 2 alpha. 1 plus 2 alpha. Right? So the want-half factor I equal to 1 plus 2 alpha. So the correct option is third option. Clear? With this, I come to end of the session. Thank you very much.